grab this. Well, thank you very much for that welcome. As it says here, I am Heather Morton from Berthon. I'm going to take you through a little bit about my background. You're probably thinking, why am I here speaking to you today? So I'll tell you why I'm qualified to do that. Why do we paint things, and what are the basics about paint? Some of you might be interested to know that I find paint quite fascinating. Watching paint dry is something that I did do on many occasions. Also, I wanted to give you a little bit of a backdrop to what the drivers are to new product developments within the paint world. You'll be surprised at some of the drivers that there are, or maybe you won't be. Maybe you might know more than I do. A little bit about what's new. And then we'll move into paint investigations, and I think that might be quite topical for the following talk in terms of expert witness and things like that. It's quite important that the right information is gathered in the right way. And then, of course, there'll be a summary and a chance to ask any questions. If you do have any questions, how do you prefer to take questions during the talk or afterwards?
During, you got me, bro.
During. Okay, that's no problem. Right then. So who am I then? Well, I was born in County Durham, which is in the UK, for those who don't know, sometime last century. And my school career included being a champion shot putter, I really was, and their worst ever 110-metre hurdler. Never ever agreed to do something just because nobody else said yes. And I did go on to work for Axe & Nobel, which was international paint, for 27 years. And I'm a graduate chemist, and I was responsible there for formulating not just the paints themselves, but my career started off formulating the ingredients, some of the ingredients that go into the paints, which I will give you a little bit of insight. And now I live on the beautiful south coast in a gorgeous place near Lymington, and I'm the paint manager at Berthon Boat Yard. Okay, so during my illustrious career at Axe & Nobel, these are just some of the products that I was either responsible for formulating in total or responsible for reformulating, tweaking, applying, managing. This is just an insight. I used to work in the powder coatings division as well. So I've got quite a long history of working in the paint formulation arena. And that's one of the reasons that Berthon took me on as their paint manager, that normally you would have an applicator who would come up through the ranks and then manage the paint shop. Dominic and Brian May, who own the company, wanted something a bit different, someone who came from a different angle. And I think when you have paint problems, it's very good to have that angle there to know what you can and can't say to the paint companies, and also the information that you need to be able to give to them. Okay, so this is just a little bit about Berthon. It does employ over 170 people. It's a bigger site than people think. It has a marina, which is about 6 acres. It's got 280 deep water berths there. Like I said, it is a beautiful place. And we also have a very strong apprenticeship scheme, and that supports the infrastructure around the company, making sure that they are training people up to take over. So they have shipwrights, carpenters, they have engineers, electricians, all employed by Berthon, and every department has a series of apprentices as well, which is really good. And of course they have their brokerage. I work in the shipyard area, in the refit part. And this is just, there's been a shipyard on that site since, what, 10th century, something like that. But how this marina has developed under the May, as the Mays have owned it, you can just see how much that's developed. Let me see if I've got the pointer here. And this is the paint shed here. We've got a huge bespoke spray booth used only for glossing, and 2 really big prep areas, so we can do up to about a 90-footer, 100-foot boat. Okay, that's enough about Berthon. Why do we paint anything at all? And there are several reasons. A lot about yachts is about what it looks like. People buy yachts because they're prestigious. Some people buy because they're keen sailors, keen racing sailors. But to paint it, you're going to add a colour, you're going to add gloss. There may be a special effect that you might want to have, and paint adds this to the boat, but it's there to protect it as well. And there's lots of different substrates that boats are made out of. Predominantly in the yacht world, you've got glass reinforced polyester, GRP boats, FRP boats, but the really big boats are made of steel and aluminium. Obviously they'll corrode. You'll get osmosis in GRP boats, especially the older builds. You're protecting against rot for wooden boats, UV damage, fouling, chemical environments, and for the really big vessels, you might even have some fire protection on there. We also might want to provide some sort of functionality. So you've got your anti-slip coatings, insulation, sound insulation, as well as heat insulation. And for really specialist vessels, I don't know if Abramovich has got this yet, but radar reflection. And you can see that you can paint functional vessels. This is a Tyne class lifeboat that we've just reinvigorated with a paint job. It's going to be a safety boat at Hinkley Point for a nuclear installation in the Bristol Channel. And there we've got just a Maxi 1100. I'm saying just, but we've reinvigorated that. She looks lovely now. In terms of yacht coatings, there are many areas of a vessel that you need to paint. Some of the same types of paints will be used for multiple areas, but you do have very specialist areas like anti-fouling, which is critical if you're racing. You don't want your boat covered in barnacles and slow you down. And also, I mentioned bilge coatings here, but for some of the bigger vessels, one of the areas that I think gets neglected about speaking about are the tanks. The coatings that you need for your black and grey water and your potable water tanks are all regulated, and you've got to have pretty good surface prep. They're often in tight spaces, so you can't re-access them. So it's an area, if you're inspecting, it can be very tricky, and I guess some of the people in the audience will know that. So the basics of paint, you've probably seen slides like this many times before, so I apologise to those who know. But paint's made up of several constituents. You have a resin, some type of resin that you want to make it, to give the property of the paint itself. Coloured pigments, inert fillers to cheapen it or to bulk it out. The solvent or a diluent, you've got lots of high solids or solvent-free coatings on the market now, so how the paint is liquefied so you can actually transfer it to a surface. So mainly what your solvents are there to do. And lots of different types of additives. I've just listed a few here, but there are lots of different little bits and pieces and pixie dust that you can add to paint to give some very important properties. So that's paint. So where do some of these chemicals come from? This is just a bit of fun, really. This is Azam. I think it's still the biggest super yacht. Built in Germany, it's built of steel hull, aluminium superstructure. And obviously it's the length of 2 football rugby pitches, and it was, I think it was about 350 million euros to build. But any guesses what's protecting the steel on the hull of this yacht from corroding? Anyone hazard a guess? It's paint. There's a constituent in there that you might be surprised. Cashew nuts. It's not the only constituent in the paint, but when I was working at International Paint, one of my first jobs as a polymer chemist was to use cashew nut shell liquid. That's its chemical structure. Obviously, this is where it comes from, called cardinol. And it's a hugely important constituent in a very important converter for a 2-pack epoxy primer. It gives massive, this structure here is very special, and it leads to being able to formulate something which is very low temperature curing, very versatile, and helps massively with an anti-corrosive epoxy product. So cashew nuts in your paint. Also, one pack some of you are familiar with, general alkyd use, standard enamels and varnishes. Soybean isn't the only one. You might have tall oil fatty acid, but certainly you'll have soya oil fatty acid in there. Linseed oil are used to make these types of products, so natural products. And this slide here, this is me on a bit of a campaign here, so you'll have to forgive me for this slide. Biorenewable. It's a buzzword in the paint industry or in the chemical industry at the minute. But I say beware a little bit about this. There are a lot of raw materials in paint that are naturally occurring. I mean, we've seen just a couple there. There are plenty more. Bentonite clays are dug directly out of the earth. And tar's been used to protect boats since Moses' time, which is true. Tar-containing products were still very prevalent on the market up until fairly recently. But there is a trend towards biorenewable materials under the so-called green ethos. They're used instead of petroleum-based products, either produce equivalents by performance or the actual chemistry. But palm oil is a common starter material for these, especially when they're looking at biorenewable epoxy materials. And I don't know if any of you know about this, but they actually tear down natural habitat to produce this. So they're taking up land that you could be used to produce food, as well as have a major impact on these beautiful creatures. Orangutans face extinction. And you also need huge amounts of energy to convert them into useful chemistry. So to me, it's a bit counterproductive, but I'll shut up now. So what are the drivers to some of the new product developments that we have seen on the market? I don't know how many of you, a lot of it is legislation driven. In terms of air quality, VOCs or the solvents that we have in paints are being heavily regulated everywhere in the world, even China. They have their own. And when you have to register, this is about registration of substances. I've jumped ahead a slide here. When you make a paint, all of the substances that are in that paint have to be registered in the territories that you're selling the paints into. And that's right down to the basics of the chemistries within the chemicals that you're using. So for instance, in Europe, there's a legislative body called REACH, which means that you have to, all the companies who are using the products, the ones who produce the chemicals, have to make sure that their substances are registered. Some of them are authorizable, which means that they're quite nasty substances like carcinogens or mutagens or reprotoxins. So it becomes quite tricky to be able to keep formulating the same products that you've always had on the market. Unfortunately, nasty substances are usually very good at what they do. They're very useful in paint. And you find that we're having to substitute these. And a lot of companies also produce paint in one territory for global distribution. So they're not just formulating for Europe, they're formulating for the USA, they're formulating for products that will go into China and then exporting them. And they have to be registered in every single different place, which makes the box of materials that you've got to formulate from quite small, actually. So it's quite tricky. So you'll find that paint companies will be behind the scenes reformulating things quite often due to legislation, just to be able to give you the same performance that you've been used to for years and years. This is just the ECHA is the European Chemicals Agency, of which REACH, the European legislation, is managed from. And believe you me, the amount of work that the chemical companies have to go into to be able to keep producing the chemicals is it's a huge amount of work. This is what I'd jump to, VOC limits, VOCs, air quality. I've just talked about the Solvent Emissions Directive here. This is what they call a bubble approach. So paint contains solvent. The amount of solvent that is emitted into the atmosphere when you apply paint is regulated. And it's regulated in Europe based on the size of the emitter that you are, i.e. the size of the yard. So if you've got small yards like Berthon, it's not a huge yard, it's sort of big in this, it's a biggish small yard, if that makes sense. But we're less than 5-ton emitter, so we don't have any restrictions in terms of the types of products that we use. We can use products that have got a lot of solvent associated with them. But if you go up to the yards that are producing the really big yachts in Europe, like your Blum and Voss's and Larson's, De Vries, those sorts of yards, they're emitting more than 15 tons per annum of solvent. And in which case, the amount of solvent that they're allowed to emit overall is restricted. So their product set, on average, can have no more than 27.3% by weight of solvent in the product mix. So for a new build yard where you're using lots of, I don't know if you're familiar with the fairing compounds that they use to refine the shapes of yachts, that's great because that has no solvent in. So if they're using tons of that, then their averages are great. But a refit yard that's mainly doing top coat resprays, top coats have got the most solvent associated with them, and they've got nothing to mediate that amount of solvent. So they're finding that their overall emissions are way above what they're allowed. So this is where you'll start to see higher solids products creeping into the marketplace, because the companies are having to produce them are selling into small yards and large yards, and clearly they've got to go with the legislation that's going to cover everyone. So high solids products will become much more prevalent. In the States, which is also a big driver, you've heard the Californian regulations there. They're very hot on, you know, an environment and what you're allowed to do. They have a different approach of categories and levels. So certain types of products are allowed to have certain amounts of solvent associated with them. And remember, if you've got a company that's making paint that's producing that for a global market, they're trying to fit into the categories and levels, and also the Solvent Emissions Directive. It's quite tricky to do. Also, from an anti-fouling point of view, anti-fouling paints are very important for keeping all the barnacles off the bottom of your boat, slime, weed, etc. Biocides are very, very heavily regulated. And in Europe, there's something called the Biocidal Products Regulation. It used to be the Biocidal Products Directive. But every single biocide on the market has to be registered, and every product that's made containing the biocide at a level has to be registered under a frame. So you're only allowed to change certain things. There's variations. The non-toxic substances you can do what you want with, but the variation of the active substances can only go down, not up, within that frame. And it all costs a lot of money, and you've got to provide a lot of supporting data to keep your products on the market. It's becoming anti-competitive, really, because the smaller companies simply can't afford to produce new anti-foulings. It's just too expensive to register them. So just a bit of an insight. And again, talking about the box of tricks that you've got to formulate with, there aren't that many of them left that you're allowed to use across all the territories. And this is also something that's quite prevalent for the bigger companies. The company that I used to work for, AkzoNobel, are actually #1 on the Dow Jones Sustainability Index. They're really, really proud of it. It's something that is a big driver for them, and other big companies are the same. Being sustainable, showing this, and quite a lot of it from the chemical point of view. They set their own internal targets. And it's often wrapped up in, I don't know if you're aware of product stewardship programs, but it's something to do with responsible care. And this came about, I think most of you would be old enough to remember the Bhopal disaster, the chemical disaster in India. Because of that, the chemical industry had such a dirty reputation, they had to do something about it. So they started to set up this organization called Responsible Care, from which companies wanted to be open and honest about what they were doing to clean their act up. So within this, companies have started to develop what they call product stewardship programs, and within that, what they're trying to do is take responsibility for their products from their inception right through to the grave. So for a paint, it would be a company taking responsibility for health and safety information as they sell their products. And also, if it's applied to a vessel, at the end of that vessel's lifetime, it may be broken down for a big ship, for instance, on a beach somewhere in India. But they're supposed to provide information to help that to be done safely. It's taking responsibility for your products all the way through their life cycle. So what they're doing is they're trying to, and with the legislation that we've mentioned as well, they're trying to future-proof their products. So they'll, beyond compliance, beyond the legislation, they'll start taking the things out that are environmentally unsound.
Sorry about that. I switched the phone off when the alarm was on.
It's all right, we're awake. So quite often, as I mentioned before, quite often the materials that are in these coatings are in there because they're really useful, but they're also very nasty. Carcinogenic mutagenic, reprotoxic. Crystalline silica is something that when you breathe it into your lungs, it doesn't come out again. It can cause an asbestos-type cancer. Cobalt dryers, now that's something that you need for your one-pack enamels. It's really useful. It used to be lead. Remember, there used to be a big thing about lead in paints and babies chewing the paint off the side of their cots, and that was banned. Well, the next best thing was cobalt, but guess what? It's just as nasty. So now that's out too. And also things like for water-based products that you use a lot of them on the internals of houses as well, not just, you don't see it so much in the marine industry for ships, but some of the products, the materials in there are something called endocrine disruptors. What they are estrogen mimics, so they're not good for the environment, putting a lot of estrogen mimics into the environment. And a lot of you remember the old TBT antifoulings? Used to turn female dog whelks to male dog whelks and vice versa. Same sort of thing. So a lot of things are starting to be removed from paints. So for paint companies to even stay where they are in terms of their performance standards, this is actually really tricky. When I was formulating in the lab, I had a team of chemists. We had, say, 15 projects on in one go. And I would say that 95% of them at one stage were all to do with environmental issues, reformulating them, taking things out just to make them perform in the same way, but product stewardship driven really, beyond legislation. So there are other drivers to new products. Innovation, obviously. There are new technologies out there. Yeah, some of it's because the legislation means we need to. But there's new chemistries or new processes. And by process, what I've seen sometimes in the yard for the smaller vessels, they're not painting them anymore, actually. They're putting some vinyl wraps on them. In my opinion, it's not as good, but for certain customers or for racing boats, it's exactly what they need because they're going to be changing their liverage all the time. So you don't have to paint everything. So that's something that's quite different from paint. It's an innovation which has started to arrive in the yacht industry. It may be that you need in additional functionality in a paint or some improved type of performance. Things do get better with time. And it may be market driven. A lot of the big yards, time is money. So you want things that will cure faster so that your production line can go faster. Or it might be just about using the same thing to do lots of different things. So lots of reasons why you would want to innovate, and this obviously drives the new products within the paint company's portfolios. So what have we seen that's new? I was talking to a lady, is it Samantha, just before we started, and you work for an insurance company? Yeah. So this might be quite relevant to some others in the audience as well. Repairable products. Allcraft 2000 is not that new. Morton have just brought a really good product out, which is, in my opinion, just as good as, and a lot cheaper. So Samantha was really good. It was good to hear. The thing about repairable products are that they can be cut and polished. You can repair them and you can't see any, you can polish them out so you can't see where the repair has been. So when you've got a boat that's just got a few scratches in it, as Samantha was describing with a Moody 36, I think she said that's in our marina at the minute, it's great to be able to just do a blow-in and just repair that part of the vessel without any detrimental effects, i.e. some paints when you repair them, you'll get down glossing due to UV degradation afterwards. And they can be available in higher solids as well, so I'm sort of linking into the legislation, the legislative drivers that we talked about as well. So these are good from an insurance point of view. You can repair these products. Thing is, most of the boats that come in have got other products on there that aren't repairable. So when you've got the paint manager at Berthon saying, no, we need to paint the whole side of it, there's a good reason for it, because the paint that was already on there isn't repairable. You would end up with cut line, what we call cut lines. If you just repair that one area that's scratched, you can't polish the paint. If you polish the paint, you'll end up where the whole side of the vessel will start to degrade because of the UV degradation. It's not a repairable product. So we're not just trying to flim-flam to get a bigger job out of it, I promise you. It is quite frustrating sometimes, but repairable products are the way forward, but they're not for everything. For a large super yacht, you wouldn't use this product on there. They've got shorter wet edge times. You see a little bit more peel with them. So they're really in the range of sort of up to your 70 footers. These are the sorts of products that you would use. And one thing to be aware from a surveyor point of view is you still need to ensure you've got enough thickness on there, because every time you polish it, you're still going to be taking some of it back off again. So it's still critical. They're not, you know, they're not the be all and end all. You've still got to be careful and look after them. Base coat, clear coat systems are becoming more prevalent. They've been around for a long time in the automotive industry, but talking about productivity, they're a lot faster to use. The base coats themselves can be applied in a day, multiple coats in a day, and then clear coated straight away. So if you've got lots of fancy designs or stripes to do, they can be a good choice, and they're available in metallic and pearlescent. They are tricky to repair. Metallics and pearlescents are really tricky to repair. So going back to the insurance side of things, when we say that we're going to have to paint a larger area, it's because we've got to be able to have a larger area to be able to lose that repair in. Cars are very easy to repair. There's lots of complex curves and lots of ways that you can lose the effect of it. But a huge side of a yacht, it's a big area. You're just going to see everything there. It's not as easy to do. So this was a Windy 39 Chimera that we, oops, that stickers in my hair somewhere, that we repaired. It was brand new, on its berth in Jersey. Boat came along, crashed into it. Not a very happy owner. But we painted the whole side of it simply because it was going to be so obvious in that big area to the forward of the window that you would just see the repair. So we painted the whole side, and the insurance company agreed that that was, you know, he's got a brand new boat. Why would he even risk that looking as if it had been repaired? One of the new products on the market as well, on the varnish side, which is very good technology, it's New Zealand are a hotbed of really good stuff. The chemists down there are very, very good, actually. You get a lot of innovative products coming out of New Zealand. This product is formulated by a company in New Zealand, and it's marketed by All Grip. It's a really good varnishing system. Your all traditional varnishes were one packs, and there is a thing about you know, being able to build the coats up, but it takes a long, long time, and the performance of them is nowhere near as good as the two-component products, the polyurethanes, but they're a lot more complicated to use. Well, this is a one-component urethane, and it comes with a primer system which conditions the wood. And I met the guys who formulated this, and the things that they don't know about wood, it's amazing. They have exactly formulated a primer so it conditions it. It penetrates the cellular structure of the wood and stabilizes it. So then when you put the subsequent coats on, it's durable. Sorry?
How many coats would you need for a typical good quality finish?
For this product, 8 to 10, still 8 to 10, but you don't have to refresh it every year. And the good thing about this is it's very flexible. The good thing about alkyds and the traditional varnishes is it flexes with the wood. So does this, and you've still got the performance of your two-pack, so it's an excellent product. It contains isocyanate though, so it's not suitable for the retail market. You really wouldn't want to let a DIYer loose with this, so it would be professional applications only. It's not available in high solids, and it's more expensive than your traditional systems, and it's really only comes into its own if you start with bare wood. So if you've got something that you're prepared to take back to bare wood or something new, that's where it really is good for optimum performance. I see. And then I mentioned this before, one of the things that the solvent that's in top coats, it's hugely important for its flow and leveling and the aesthetics. And if you're going to get a claim on a vessel, I would say that a huge chunk of the time it's about the appearance, and it's all a bit subjective. So having solvent in your top coat, you need to protect as much of that as you can. So going back to the VOC regulations, what the paint companies have been doing are looking at the protective coatings underneath that, your epoxy primers that go underneath, and take solvent out of those, because the look of them isn't as important, obviously. They still have to have good flow and leveling for a good system, but this is where they're taking the solvent out. So for the big yards, you'll see higher solids products having to be used, especially in the refit arena where they don't have the fillers to mediate the amount of solvent they've got. So they'll take solvent out of the epoxy primers. So it's good. It allows them to meet their VOC targets. You can get more on because there's less solvent there, so you're putting more paint on the side of your vessel per litre. And also it's got improved chemical, there are some advantages, improved chemical conversion, chemical resistance. I won't go into the technology, but there are some advantages. But you've got a higher cost per litre, and the working time, when you mix two components together, obviously it's reacting in there, so you've only got a certain amount of time that you can use that product before it passes its pot life. These things, where you'd have 4, 5, 6 hours, you might get 1 or 2 hours. So they've got to work faster with these products. And also, from a surveying point of view, they've got shorter overcoating times. Traditional epoxy primers have got long periods of time before you need to put the next coat on. Higher solids products, pretty much, especially getting near the solvent-free area, they've got very short overcoating times. So you only might have 2 days or a week to get a product on top of it, where you used to have months you didn't have to worry about it as long as you cleaned it. And they're more sensitive. Because you've got less solvent to help them flow out, they're more sensitive to the substrate preparation that you've got underneath them as well. So I tried to put things in here that would help in terms of the surveyor side and the audience as well, and maybe help with the insurance side as well to understand some of the issues that do get presented to you. One of the other areas that's come into the commercial vessel area, foul release systems. We mentioned biocidal products regulations. These systems deter fouling from settling on a surface because of the surface energy effect. You can see that on the little picture at the top there, the water's boiling up on it. Things can't stick to it. It's a very slippy surface, easy to clean. And for big vessels, cargo vessels that are backwards and forwards across the ocean, the fouling is just sloughing off all the time. So there's huge fuel efficiencies for these people. They're buying carbon credits. That's the way that they're selling products at the minute. They're actually buying carbon credits because of the amount of fuel saving. In the yacht arena, it's not so prevalent. Fuel cost is it's not such a sensitive issue to guys who can, or guys and women who can afford these types of vessels. And also, because they're static for a lot more time, the fouling will gather on there, but it's easy to clean off. But you have to go down, sometimes you have to get divers to go down to clean it, or you have to lift them and scrub them. So it's starting to make its way in, and when we're not allowed to use copper and other chemicals like that in anti-foulings, maybe we'll see more of this. And there's lots of other things coming on the market as well that are touting to be anti-fouling type products. But foul release is an area that you might see creeping in. They're very difficult to repair. The chemistry is not easy, and it affects other chemicals. It's full of silicone, which is death to a top coat. You'll end up with fish eyes all over it. So you have to apply them in a different part of the yard, a different shed. So again, from a surveying point of view, it's just things to be aware of. If they do creep into the yacht market, there's a whole different way to be able to think about these and to be able to repair them and to use them. So these are some of the possible developments. When I was in the laboratory, I left in mid-2012, some new chemistries were starting to creep in. Interesting things for the top coat arena, again because of legislation, but also performance enhancements. So something for the techies in here, something called polyaspartics. These systems are very, very fast. They almost can be used solvent-free. So again, VOC regs, this is great. You can even use them in California. You can get a lot more product on. So if you're looking at problems that you have with top coats, again for the surveyors out there, and looking at problems on vessels, you can apply more coating thickness per coat. So you don't have the same problems that you get with traditional highly solvented products. There are some cons at the minute. I mean, basically, this technology can be used in the yacht market. It's just a case of the paint companies just getting wiser about it, developing them, making them suitable for yacht applications. And the same with polysiloxanes. These are a different type of chemistry. The good thing about these, and there's no isocyanate there, because isocyanates are not nice materials to use. They can only be applied professionally by spray. So having a product without isocyanate in that delivers all of those other things that we talked about, low VOC, so less solvent in there, and the same durability and physical properties. At the minute, these are the types of chemistries are costly and they're not proven in the yacht market. Right, so I was going to move on to paint investigations now. The key thing is that if you're doing an investigation, you have to know as much about the vessel before you arrive at it. And I'm probably telling some of you how to suck eggs, but it's really key to understand as much as you can before you arrive. What type of vessel? It might sound obvious, but what type of vessel is it? What is it made of? How old is it? And if you've got a previous history about, you know, how often it's been painted, what it's been painted with, all of that is hugely useful information. What's the area of the vessel above and below the water, depending on what sort of inspection that you need to do, and the configurations. Access to what you're trying to look at may be very, very difficult. Knowing that beforehand helps you to be able to plan how you're going to be able to do the investigation. And also make sure that you've got the right tools with you to measure, to take samples. For your assessment, look at the affected and non-affected areas. You need to be able to compare measurements, whether it's physical or visual, from both of those areas. And you might need to take some samples away. Obviously, you'll have to have some sort of permission and agree, have some insurance, and who's going to repair this afterwards. But if you can take samples or be able to destructively test, it can be very useful. And the main thing that I've seen that I don't like in that side of the industry, no disrespect, is where it's opinion-based, not factual. When you gather in information, it is just the facts. Literally, you need data, you need to be objective. It's not about, you use your experience, but it's not about supposition. And I've seen a report recently where it is, there's nothing to back up what the guy who was asked to do the investigation, got no data to back up some of the conclusions that he's drawn. It's simply his opinion, which is clearly not right. If you're measuring in sample, photos, lots of photos, it's hugely helpful. And look for the obvious. There's something called Occam's razor, which is roughly translated, it's the simplest answer is usually the right one. And if you look at it as what I would call a cause and effect, you need to look at your materials, your methods. You need to think about it as a holistic approach here. What is the problem? So what could have caused it? And one of the things that you need to be pushing for are measurements, and that's the yard. The applicators should be keeping good records of what they've done. What was the environment like when they were painting? Have they measured the temperature? Have they measured the humidity? Did they measure anything about the paint? And one of the things that we do at Berthon, and it's good practice in any yards, you have these paint logs. So any customer could come along and ask for a paint log, and rightly so. What did we use? What were the batch numbers? Batch numbers are important to be able to trace it back to the paint companies to find out if there were any problems with the paint itself. Temperatures, humidities, what the application equipment was, what the gun settings were. Lots of things, lots and lots of good information. It protects the yard and it helps the paint companies to be able to do a proper investigation. If you're taking samples, take as large a sample size as possible. I mean, this is a good example there in the picture of a decent size. If you can get bigger than that, then fabulous. We did have one yacht that came to us that had some damage on the transom. The dinghy had rode up the back of the transom, so asked us to repair it. And when we looked at it, we did some adhesion testing, and about 4 or 5 coating layers could be stripped off quite easily using what you would like a traditional wallpaper scraper. You could literally just pull this off, and we thought, hang on a second, if this is the transom, what's the rest of it like? And it was a 56-footer. And so we did a small investigation on the top sides, got it agreed with the owner, and you know, you pay to repair it if there was nothing wrong. And we literally we started at about 9 in the morning, and by 4:15 we'd stripped the boat of layers and layers of paint. And talking about sample sizes, they were rug sized. You literally could just peel the paint off. And that was to do with poor surface preparation, missing an overcoating interval. But the amount of sample that we were able to give the paint company, they came back with quite a lot of useful information for us. You need to take it from different areas and reference that. And one of the things that I don't know might be have knowledge about, but you need to put it in an airtight container if you're taking a sample, not necessarily a rug-sized one, but you need to preserve the chemicals in there, the solvents, because the paint companies, if they're going to do the independent laboratories can do the testing on the air in there for solvent vapors and actually extract solvent out of the samples. So it's important to protect them and put them in airtight containers. And also making a note of the area which the samples came from. We had some information come back to us for one of the vessels that we put some varnish on, and the owner had gone to the Caribbean, and then there'd been some peeling issues, some lifting of varnish off his vessel. So he just took a whole load of samples, put them all in the same bag and just sent them to me, but I didn't know what part of the vessel that they'd come from. So it's not so useful just to, you know, you can work miracles, but you need to have a bit more information. The next set of slides are just some cross-sections and some information, flake samples that have been taken off vessels. How am I doing for time, by the way? We're okay. You can tell a huge amount just by taking just with some physical measurements. This is a scan and electron micrograph here. You can do lots of chemical analysis as well. But this is a product which is actually based on cashew nuts. This did have cashew nut in there as well, but it's got aluminium flake in. It's a very good anti-corrosive product. And you can see here that you can work out there's two coats of primer on there, and because you've got a scale there, you know exactly that the right thickness was put on there. So it is very useful to be able to get samples, to look at them in this way. This was an issue where we had a top coat, when I worked at the previous company, top coat that was blistering. So we took a sample and turned the flake over, and you can measure the scratch pattern on the back as well. And it turned out that this hadn't actually been prepared properly at all. So the adhesion, and we were seeing some osmotic blistering because of it. The paint was lifting away. So again, just some simple analysis with some flakes can tell you a huge amount about things. This is a top coat system over a pink filler, which is an all grip filler. So you can see, again, it's about the layers there. How have the layers been built up? Have they been prepared properly? You can see a lot from this. You've got your top coat, your undercoat, layers of high build primer. You can see here that they've gone back. They've decided that it wasn't fair enough, and they've gone back and put more of the high build primer over the top of the undercoat. So they were going to finish it here, and then they've had to go back and refair it. So it gives you a history, a picture of what's gone on the vessel. These are anti-foulings. And quite often with anti-foulings, you take your boat out every year, another couple of coats of anti-fouling, put it back in. But at some point, that layer is going to build up past a point where it can adhere to the boat. And you also get leach layers building up. You can see on this one here, that's the freshest layer of anti-fouling, the last layer that was put on. This is where it gave up. But in between, you've got all this other anti-fouling. You can still see the copper in there. And for here, that's where the copper is depleted. So that's where it's done its job. But it leaves behind quite a friable matrix. And depending on the types of anti-foulings, that can be bigger or smaller. But eventually, that leads to failure down here because the anti-fouling dries out. It can't cope with it anymore, and it just literally falls off. So every now and again, you have to take the anti-fouling off, reprime it, and start again. And we do see that a lot. Again here, a vessel that's faired, so these will be off the bigger vessels where they use a lot of fairing compound to get smooth surfaces. But you can see what's going on here. That's a very resinous layer. That doesn't look as if it might have been mixed correctly. and chemical analysis could show you. They're very clever, these paint companies. If you've got a 2-component product and you've got a certain mix ratio that you need to adhere to because they're sensitive to it, they'll put a trace, or they'll work out how to be able to measure exactly how it was mixed. And they'll have a trace element in one of them that they can do some fancy analysis with, and they can come back and say, no, sorry, you didn't mix it in the right proportions. And they have the data to back it up, they really do. So beware. Again, another product here. Again, going to fairing compounds, there have been some quite big issues with in the big builds where the fairing compound is used such an extensive amount that it becomes part of the construction. And if you get voids in there, which they are prone to, then it can cause cracking problems, which they have seen. So again, cross sections through you can see where problems have emanated from. A bit more of the same will fall through. This is one that came into our yard. We were asked to paint a small motor yacht, a 50-footer, just the blue stripe. And when we got it and we sanded back the gel coat, which was very tired, it was completely full of pinholes. I mean, everywhere. And it took us quite a long time and a lot of effort and a lot of talking to the owner, who I think thought we were just trying to get more money out of him. It wasn't. It was because it was full of pinholes. So something to watch out about. A neat trick is to take the solvent onto the surface, and as it's evaporating off, you see defects much more clearly. He also had cracks, port and starboard, midships, which were clearly visible. Again, rubbing the solvent across, and some damage to repair there too. And that's what it looked like in the end. He still wasn't happy though. This was the boat that I talked about where the paint would peel off. I mean, this is just a small sample of paint peeling. We literally had sheets of it coming off, but look how easily that was just peeling off the surface there. And that's what she looked like when we'd finished her. So it was good for us because we got a whole repaint out of it in the yard. The insurance company didn't pay. The previous yard who painted it had to pay, which, you know, it's the way it goes. It could happen to us. I won't go into this for the guys, the surveyors in the audience. Let's just say there are lots of different defects that you can get in relation to paint, and being able to take the right measurements and have as much information as possible about how the paint was applied and the environment it was applied in is gold dust to be able to complete an investigation and back up an insurance claim depending on, you know, who might be culpable. Inspection equipment's very important, and something, again, these are destructive testing methods, so you need permission to be able to do this. The pat tester is literally taking chunks off, putting a little dolly on the side and pulling it off to check adhesion. Wave scan is becoming very important in the super yacht arena or the luxury craft arena to be able to measure more accurately the actual appearance. Often you'll get an owner's representative or an owner coming up, and there's another 50 million. The boat's going to be delivered, but they've got 50 million more that they need to pay. They don't necessarily want to pay that, and they'll say, I don't like the look of it. And you say, well, it looks fine, but you can't really prove it. They don't like the look of it. But actually, when they're starting to measure more things about it, this measures the actual appearance, surface appearance. So it's becoming a lot more prevalent, and they've got ISO standards in place now to try and help that industry to regulate itself. So I've raced through. I think I'm just about on time. So hopefully I've given you an overview of who I am, why we paint, and some fun topics about strange materials that are in paints. A bit about drivers to new product developments, and legislation is clearly an area that it's the biggest driver really for most of the paint companies. A little bit about what's new and some paint investigation tips. And thank you very much for listening to me, and does anyone have any more questions? Nope. Oh, sorry.
When you have something that's been passed by the European Union and it has that REACH certification, is that then able to be exported from one country to another country within the EU, or does each individual country have to pass that?
No, it can be, as long as it's within the EU and they've got, You have to have a body that's responsible for registering it, a separate body that's registered. But as long as it's within the EU, it can be transported around.
So once it's passed legislation for the biocides in England, let's say.
Biocides are completely different. That's not regulated under the REACH regulations, the Biocidal Product Register, and member states can have stricter regulations and things that are and aren't allowed in their country. I think Holland was I think my facts are correct here. I think Holland have, in some parts, banned the use of copper altogether. But you can still use it in the UK waters. You can still use it in some parts of Sweden. But you've got the brackish part of Sweden and the fully saline coastline of Sweden. Different regulations depending on which coastline you're on in Sweden. So it can even vary within a country. Biocides, very complicated. Yeah?
In your experience, the problems that you've found and seen over the years, which are due to the product and which are due to the applicator? What sort of percentage?
A percentage. When I worked for the paint company, 100% applicator. Now I work for the boatyard, it's always the paint. And I think I'm not answering the question very well because I think there is so much subterfuge in there. Honestly, and not because I'm biased, because I'm a paint chemist, if there's something catastrophically wrong with the paint, you definitely know about it. It's often about a mixture of environmental conditions and application, I'm afraid, quite often,
So
mostly.
there's not too much wrong with the actual paint formulation itself?
Quite often there's not, no. Sometimes there is, and like I say, it happens, it'll happen in lots of places, and you'll start seeing it. So mostly I think it's mostly environment and application, if I'm honest. Or using it in an unsuitable place. Yeah?
Have you ever been involved in spectroscopy matching faded paint?
The colour.
Mixing to match?
Yeah, colour matching, yeah. Yeah. In what context?
Or just, to avoid photo repaint?
Yeah, you could, up to a point. The thing is, when a boat fades, it doesn't tend to fade evenly. So if you're matching one part of it, you're not necessarily matching another. So you would still put a caveat in there that to the best of your ability, you're matching it, but you still might see some colour differences.
Judgment of the human eye, isn't it?
A lot of it is, yeah. And some colours are easier to spot changes in than others because of the colour space. Yeah?
Is there a simple, non-destructive tool for measuring paint film, paint thicknesses?
Paint thicknesses. Oh, you're going to have a guy talking to you later on. Yes, there are some tools that are measuring. On metal surfaces, yes, definitely. On non-metallic surfaces, it's trickier, but there's more equipment being developed.
Is there a tool that is economical that's there to use?
Oh yeah, DFT gauge. The only thing is, it doesn't tell you about the layers. It only tells you what the multiple. And if you've got anything in there that's insulative, like a filler, you won't be able to use it on that. But I think you're going to get a lot more about that in the last talk.
No, I think that's the steel thickness we're looking at later, not paint film.
Oh, is it not? You can get tools like ultrasound and all sorts of new tools that you can use, that you can use to start looking at thicknesses of paint films, even on insulated surfaces. But it's really tricky, and the best way is the paint inspection gauge, which is but it's destructive, so you have to repair it. The PIG, as it's nicely known, where you literally look down a microscope, you put a cut at an angle, and you can tell exactly what's on there. It's useful. Yeah.
Hi. You talk about paint faders. One of the big series of paint faders I tend to find is the yards where they've done the osmosis treatments, and then the moisture content of the hull has clearly been too high.
Yeah.
Coatings.
Yep.
What's interesting is that most of the manufacturers don't actually put a clear recommendation on the actual tin, and within the paper leaflet you get on the internet, it's not there. It says dry.
Yeah.
So when you phone them up, they say about.
Yeah, it is.
And no one actually.
They're deliberately being evasive.
Companies are very evasive about what it used to be. When I first started using the old products, it used to say clearly 5% or 7%. But
Yeah.
it being brought out.
They'll go,
Yeah.
Yeah, they do, because it's a very litigious world we live in, and they won't commit themselves because each boat is different. But in general, you're right, 5%. Depends which meter you use. And if you're using the Tramex, it's less than 40 on the comparative scale. The old Sovereign meter, it was less than 5%. The new one, I think it's a scale of 15. But yeah, they won't, because we did have a boat that wouldn't dry out, and the West SP, Gurrit, they would not commit. They'd say you can try it, but they wouldn't put a stamp behind it.
It's very hard to actually now find. It's very hard to actually find that vital figure from any of the paint companies now. It's not on any of the.
Yeah, I don't know if they ever did actually. Maybe they did, but yeah, it is difficult to get the information. But from now, I mean, the Boatyard point of view, yeah, 5 or 40, or the figures are there. But it is a little bit, there's never a guarantee that it's going to work completely, especially if you've got a balsa core. I mean, whew, yeah. Yeah.
So many of us sort of surveyors are sort of general practitioners, and we might get called in to see a sort of paint problem, but don't have the expertise to fully sort of analyse the problem. From life's experience, I'd be hesitant to just put it going straight to the manufacturer.
No, I agree with you.
And what would be your suggested route for pulling in the expertise or finding the right lab to do the analysis?
I would get yourself an independent, truly independent paint inspector who knows what he's looking for, or knows how to find what he's looking for. And then in terms of, the thing is, in terms of testing, I have to say this, the paint companies are the experts when it comes to testing the products. The independent laboratories are not, they're not wholly paint focused, so it is really tricky. I think that the key is to get someone who really knows the product so they can really hone in on the type of analysis that you would need from it. So a good independent paint inspector with a good background in paint is probably what you need.
The independent inspector wouldn't necessarily have a lab.
No, but they'll know exactly what you would need to look for and analyse. They wouldn't just send a flake out and say, look at this, it might be this, it might be that.
Could they do a great deal without going to the lab?
Oh, there's a lot you can do without having to go to a lab, yeah, definitely. But analysing those paint flakes there, you know, doing the scan and electron microscopy, a general laboratory would be able to do that for you and then just present you with the pictures, but you'd need someone who was used to knowing about coatings that would know exactly what that meant.
Complementary is copper coating and products like that.
Oh, yes,
Where does that stand in the world of the environment and so on?
It's full of copper. It's got a huge amount of copper in it. So eventually, and I don't know what the time scale will be.
Like that, is their day numbered?
Yes, in my opinion, yes. And they already are in Holland, because you can't use copper in some parts of Holland, I think. I don't know if they revoked that, but it certainly did get banned. So yes, their days are numbered. They're part of that beyond compliance. You know, the companies are looking at, well, biocidal free, so the foul release systems. Yeah?
There used to be samples in the River Yale on off rafts and that.
Yeah, they do. They still have rafts out there. They've got one in Burnham on Crouch and Newton Ferris and Singapore and all around the world. They still do testing like that on boards, anti-fouling boards on rafts. Yeah, it's subjective because it's fouling challenges are different around the world depending on the sea temperatures, and even around the UK coast they can hugely differ, the fouling challenge. And season to season it can differ as well. So it is quite tricky actually. So you say my anti-fouling used to work really well and it didn't work so well this year, probably because the fouling challenge has changed a bit, because they're not a catch-all. They have key biocides and boosting biocides. It's all very complicated, but they're there for different reasons and they're quite fine-tuned. So sometimes they work better than one year than another.